I am not happy with my choices of tools for managing Kubernetes manifests. I've tried many, and after the initial excitement, I always end up disappointed. Now, to be more precise, I always ended up disappointed when working with more complex or larger projects, not with just simple, silly manifests, right? Like almost everyone, I used Helm for a long time. I switched to Kustomize as a result of frustrations with Helm. I moved to JSONnet and Carvel YTT and CDKs out of frustration with both Helm and Kustomize. And now I'm not happy with any of those, so I set out to find something better. But before I started looking, I decided to make a list of requirements, and with those at hand, I should be able to find a solution that fits my needs. Let's start with the list. Who knows? Maybe I will realize that I do not need to change anything and that I'm just being picky. Here's what I'm looking for when working with complex or large projects when Kubernetes manifests are concerned. One way or another, Kubernetes manifests end up being YAML or JSON. No matter which tool we choose, that's what is sent to Kubernetes API. It does not matter whether we talk about Helm or Kustomize or CDKs or YTT or something else. The end result is always YAML or JSON. Now, the important thing to note is that both YAML and JSON formats are all about data. In case of Kubernetes, data is used to represent the desired state of a resource based on a resource definition. We cannot expect Kubernetes to understand random stuff. When we want to have a resource, the definition of that resource needs to match the schema of that resource definition. The keyword here is schema. Hence, it should come as no surprise that the first requirement is support for schemas or structs. I need to be able to define a schema or a data model that represents data I'm trying to define. Otherwise, without having a schema, I cannot rely on any tool to help me write manifests. There is no code completion, no validation, no nothing. Helm does not have any concept of schemas or structs. Heck, Helm templating does not even understand YAML, and that is silly. It does know how to parse output of free text templating into YAML, but that does not change the fact that Helm templating is based on free text templating, oblivious of the existence of YAML. Hence, it would be silly to expect Helm to understand data structures or schemas. The same can be said for Kustomize. Actually, not the same. Kustomize does understand schemas and structs since it's YAML and YAML is based on data, but YAML itself, or to be more precise, Kustomize does not have an option to use a schema to validate manifests I am writing. Actually, I could probably instruct my IDE to validate YAML against the schema, but that's not what I'm looking for. It would have to be guessing which type of resource I'm writing, and guessing is not a good thing. So Kustomize fails this one as well. CDKs allows me to write manifests in Go, TypeScript, or any other supported language, so naturally schemas are structs when working with Go or whatever is the equivalent in other languages. Finally, Carvel YTT allows me to define schemas. It's baked into it, so that works well. No complaints here. So, to summarize, when schemas or structs or data models are concerned, Helm and Kustomize fail this requirement while CDKs and Carvel YTT pass it. 2 against 2. By the way, if you're not familiar with any of those tools, feel free to check out those videos. Now, most of the time, I do not really want to define my own schemas. They're already defined in a Kubernetes cluster or a Git repository. No matter whether it is a resource definition baked into Kubernetes or a custom resource definition, I should be able to say something like, I want to work with this resource, so please generate the schema and make sure that what I'm writing is based on it. That's not much to ask. As you can guess, given that Helm and Kustomize do not understand the concept of schemas, I cannot expect them to import them from a Kubernetes cluster or from elsewhere. Hence, both of them fail this requirement. CDKs, on the other hand, shines here. It already comes with libraries that act as schemas, or to be more precise, as structs. On top of that, I can convert any custom resource definition into a struct, so I'm fully covered there. Carvel YTT, on the other hand, does not do that as far as I know, or to be more precise, it is not as simple as saying import this schema. As a matter of fact, YTT schema is closer to Helm values file combined with validation functions than to a schema. Now, I might be wrong on that front, and if I am, please correct me in comments and I will put a note here or somewhere over there. Unless you see it, I'll say that YTT fails on this one as well. Next is type checking, which goes in line with the need to have schemas or structs. Kubernetes resource definitions have to define whether something is a string, an integer, a boolean, and so on and so forth. That part is important since I should not put a string value into something that, for example, accepts only integers. Since this is still related to schemas and structs, Helm and Kustomize fail automatically while both CDKs and YTT pass. Writing something in a programming language like Go naturally means that I have to define types, or that predefined and generated libraries have types, unless I choose to use JavaScript, which implies types for values. Carvel schema declarations, on the other hand, include types from schemas, but schemas are not really schemas, and now I'm not sure whether to give it a pass or a fail. Let's go with a pass. Let's say that it passes this requirement. Another important feature is overlaying. More often than not, for resources of the same type, I want to have a default set of values and then overlay them with those that are specific for a given resource. That saves a lot of time in writing and removes clutter from my definitions. Helm does not support overlaying, even though I could accomplish something similar with values files. Still, it's not the same, so failed. Kustomize is all about overlaying. We can patch any YAML manifest with another YAML manifest. That's a big pass. CDKs is based on programming languages, so even though it's not officially called overlaying, I can do something like that depending on the language I choose. And finally, Carvel YTT is a mixture of templates and overlays, so that one passes as well. Next, I need some kind of policies, constraints, validations. What that means is that I want to be able to define rules that will prevent me from doing something that I should not be doing. For example, I should be able to say that a specific field is not only a string, but that it cannot have more than 70 characters, or that some other field should be an integer that is greater than 0 or smaller than 1,000, for example. Helm and Kustomize do not have that, since such rules should be defined in schemas and structs. It could be done with CDKs, but it's painful, so I'm discarding it as well. That leaves us with YTT, which works great on this front. I mean, it does not have schema, but schema values, but we can use it to validate those values, and it gets a pass. Finally, I want something without a steep learning curve. Whichever solution I pick, I'd like it to be easy to learn. This is the part where Helm and Kustomize shine. Sure, you can make Helm charts and Kustomize overlays so complex that no one will understand them, but in general, they are very, very easy to learn. If you understand how to write YAML and you do understand Kubernetes, you will be able to write Helm charts or Kustomize overlays in no time. Initially, CDK seems like an easy solution, since all you have to know is the programming language of choice and spend some time learning CDK's structure. However, the more CDK's code I wrote, the more I realized that there are some things that make my life miserable. I suspect that comes from the fact that CDK itself is written in TypeScript with some dark magic that allows us to work with it in other languages. Go implementation, for example, is bad, really, really bad, with a lot of boilerplate code. If I never see JSII conversions, I will die a happy man. Now, TypeScript or other languages might be much better, but judging by the Go implementation, I'd say that learning curve is not as shallow as I would like it to be. Finally, YTT is the worst of the bunch. It's nowhere as easy to learn as Helm or Kustomize, and it does not have the benefit of being a programming language that you're already proficient in, like CDKs. It's a language of sorts that you have to learn, and my experience is that it will take a while. You will quickly say, okay, I understand this, only to realize a moment later that you don't. It is quick to pick up, but it takes a while to master. Now, to be fair, once you do become proficient in Carvel YTT, you will realize that it is great. But the process to get to that stage will take a while. So, as you can see, none of the formats and tools I spoke about fulfills all my needs for complex or large projects. If you have something simple, I recommend Kustomize. That's a clear winner for majority, since many of the requirements I mentioned do not apply to situations when all you have to do is write a few lines of YAML. But when things are more complicated, try to move that complexity inside Kubernetes in form of custom resource definitions and controllers or operators. That way, what you're defining is going to end up being simple, and I would still recommend Kustomize. But today, I'm not talking about either of those cases. I'm talking about writing something that results in hundreds or thousands of lines of YAML with a lot of repetition, the need for validations, code complete, and so on and so forth. In those cases, neither Helm, nor Kustomize, nor CDKs, nor YTT are good enough. If I would have to choose between those, if those would be my only choices, I would choose either CDKs or YTT. Those are the two closest tools or formats to what I need, but they're not quite there. There's good news though. I think I found the one that fits all the criteria. Can you guess what it is? If you say JSONet because you saw that it is conspicuously missing from the list of tools I discussed, you're wrong. It does not fit the criteria either, and I did not mention it only to keep this video from exploding. The solution might be Q or CUELang. Let's talk about it and see whether it fits the bill. So, what is Q or CUELang? The name itself stands for configure, unify, execute, which after the initial what the heck actually makes a very good name. It describes well what it does. Q is an open source data validation language and inference engine. It is a programming language that allows us to define data structures, that's the configure part, to unify data, hence the unify part, and execute it in an attempt to produce the final output, hence the execute part. I know. That was confusing, so let me try to explain it in a different way. Q is a superset of JSON inspired by Go. If you would like a graphical explanation, imagine that JSON and Go had a baby and named it Q. Now, you might expect me to do an in-depth exploration of Q and teach you how to work with it, but that's not what I will do. Instead, I want to see whether it can fulfill the requirements we discussed, and during that process, show you how we could solve each of those. Think of what follows as an introduction to some, but certainly not all, of the features of Q. Let's go through all the requirements we discussed, but this time see how many of those Q fulfills. The first requirement was for the solution to understand data, since data is what we are working with when defining any type of state, and Kubernetes manifests are all about defining state. And we can see that from a video Q file that contains some sample code. And in this case, the first video, the IDP has the ID set to some value. Now, you might say, this is what YAML and JSON do, and you would be right. Those are treating data as data, unlike Helm that treats everything as free text, completely oblivious of the fact that it should work with data, or to be more precise, with YAML. Now, it will become obvious why that matters in a moment, so be patient. For now, data is checked. Next, we have a schema, which in this case is video. We can define what something is and make sure that entries of that something are based on it. In this case, IDP, top 2023 and top 2022 are all based on the schema video. Actually, it's more than only being based on a schema, or in this case, a struct. We'll get to that in a moment as well. What matters right now is that the ability to have and use schemas or structs is checked. I can output data from that file as YAML with the export command, even though, as I will argue later on, you probably do not want to do that. And I'm not limited to YAML. I could also output it as JSON, and I could extend Q to output it to other formats. That is the benefit of using something like Q. It works with data structures instead of working with a specific format. As a result, those structures can be output into any format you want. Now, most of the time, I do not want to write my own schema. When working with Kubernetes, schema of any resource is discoverable. I should be able to point Q to a Git repository or to a cluster and say, I want to work with this definition, generate schema for me. Otherwise, I would be wasting my time writing schemas that can be auto-generated. Here's one example. This definition imports all the schemas, or in case of Q, structs for V1 core Kubernetes resources. How did I get it? Well, all I had to do is execute kugetgo command and point it to the GitHub repo of Kubernetes itself. Further down, I'm creating a new dataset called service and instructing it to use the struct, the schema of the imported service. So, importing schemas or structs, checked. Now, going back to the video queue example, the video structure has fields and each of them has a type. All but the last ones are strings. Now, let's see what happens if, for example, I change the value of the likes field to a string and I try to export data. It errors complaining that the value is a mismatch. It expected an integer, but it got a string. That's type checking. Schema fields have types and Q will make sure that the values are the correct ones. If I would use Visual Studio Code or IntelliJ or any other editor with Q support, I would see the error right away in the editor. I wouldn't even need to execute any command. So type checking is checked. Now let me quickly undo the change before we move on. The next on the list are overlays and default values. To begin with, we can see that the video struct is a dataset as well. The URL has a default value, as do the description and likes fields. Now, when I'm creating ITP, what I'm doing is using video with its default values and then overlaying it with my own ID and title and description and URL and likes values. In other words, I'm overlaying all the fields. But if you take a look at the top 2023, we can see that the description is missing. What that means is that top 2023 overlays all the values except the description, which retains the value from the video struct that is set to n/a or not available. Let's see whether that's really the case by exporting that file. There we go. Both top 2023 and top 2022 contain the master struct video that was overlaid or combined with their own values. So even though those two did not specify the description, they still got it from the main or master struct. Hence, overlays checked. Schemas or structs and types and overlays are not enough. We should also have a mechanism to define policies, constraints, validations. Video defines title not only as a string, but it also sets it to be a maximum of 70 characters through the max runes function. Similarly, likes has the default value of 0. It is an integer and it must be greater than or equal to 0. Let's see those two constraints in action. I will increase the number of characters in the title beyond 70 and change the likes to a negative number. If I validate the file with the kuvet command, we can see that it complains about the title having more than 70 characters and likes not being greater than or equal to 0. Validations are automatically performed when exporting data, so we'll get the same output with QExport as well. So, policies, constraints, validations, and similar things checked. Q understands data. It has schemas. It can import schemas. It has type checking. It can combine or overlay data, and it allows us to define policies, constraints, validations. But there is one requirement we did not discuss yet. Does it have low learning curve, or is it easy to learn? Well, that depends on what you're comparing it with. It is certainly harder to learn than Helm or Kustomize. Compared to CDKs, you need to learn a new language, so the curve is steeper as well when compared to it. The only one that requires you to learn as much or more than Q is YTT. So the learning curve is, well, it could be better. It's not hard, but it could be easier, so not checked. That's the only failed requirement so far. Now, to be clear, Q is not hard to learn. Once you pass through some weird syntax like the usage of hash signs and question marks and ampersands and asterisks and so on and so forth, none of those things is a big issue. The biggest hurdle might be immutability. It might take a while to get used to the fact that once a value is set, it cannot be changed. That might look like a limitation, especially when overlaying data structures. But all I will say on that subject is that immutability is a good thing that you will probably appreciate once you get used to it. Still, if it's harder to learn than Helm, Kustomize, or CDKs, except maybe YTT, why would you use it? That's the question probably, right? Well, it offers quite a few benefits when compared to those tools or formats. It feels liberating to use a language designed to deal with data structures, and the only real competitor to Q is YTT and maybe JSONnet. Now, this is probably the moment when you're asking yourself about other features that we might expect from similar tools. But first of all, this is not a tool. This is a language. Still, the question stands. Can we build and package manifests with Q? Can we publish them to a registry or output them to a file that can be stored in Git? What to do with all other features tools like Helm and others have? Well, you can do all of that with Q directly. After all, it is a language and you could create your own functions that do whatever you need it to do, but that's probably not something you want to do. After all, there are very few of us willing to invest time in recreating the features that other tools already have. Luckily for you and me, the number of specialized tools that are based on Q is growing. I will not cover those in this video because we're already over the time, but I do promise to release a separate one on that subject. I already started working on material about a tool that I will not reveal here, but just subscribe to the channel. You will find out about it soon, probably after this video. All I will say about it right now is that it is very, very, very promising. So in one of the next videos, I will show you how to use the mystery tool for the operations we typically do with Helm and similar tools, but using Q instead of Helm templating and with some features which are much better designed than what we have in Helm. That should give you the right incentive to subscribe to this channel if you haven't already. You probably have, so. Anyways, until then, I strongly recommend that you check out Q. If you learn it, you will be able to leverage that knowledge with many tools, not only those related to Kubernetes manifests, but also those related to other types of configuration, continuous integration, and so on and so forth. There is a strong chance that the future of configuration and data or state management will be based on Q. From my side, all I will say for now is that I am rewriting all my complex or large definitions into Q, and I'm loving it. I still keep Kustomize for simple stuff, but Q is my go-to choice for everything else. Thank you for watching. See you in the next one. Cheers.